This video is going to show you a few tools related to creating your building sections. In the book, you start out by opening the exterior elevation drawings and then doing a save as, and then turning those exterior elevations into building sections. Sometimes, depending on what order you develop a project in, you might do that in the reverse order. You might start by developing your building sections and then deriving the exterior elevations from that. In this particular video, I want to show you how we would create the stair section that you see here. So we're going to copy these two lines down that represent the floor-to-floor height, just so that we can do this example adjacent to the finished product. The first thing we're going to do is array the basement floor line up. And to do that, we first need to figure out what our riser size is. So we'll take the floor-to-floor height and divide it by the maximum allowable riser height. And then whatever that number is, we'll increase it to the next whole number and then divide that number of risers again by the floor-to-floor height, because we have to have a whole number of risers. We can't have 15 risers at the maximum height and then just a partial riser at the end. All the risers have to be the same height. So after doing that math, we figure out that we need 16 risers. That will turn out to be 6 3/4 inches high. So we start the array command. We pick the line that represents the top of our basement floor. We right click, and then we're going to specify 16 rows that are 6.75 inches spacing. And then we're going to only have one column. And you can see our preview below. Turns out that it looks right. There's one extra space to get us up to the floor that appears to be the same space as the others. So we can click Close Array. We can verify the spacing using the Measure tool. So we can actually snap to those points. In the end, we're going to want to explode this array so that each line is separate. Next, we're going to draw a line where we want the stair to start at the first level. And then you can see that the stairs are 12 inches, or actually they're 9 inches, sorry, for residential. So we're going to array this again, except this time we're going to have a certain number of columns. And maybe we don't know how many columns we need yet, so we'll just type the space that we need. We only need one row. And then in this case, we can just drag this in our section. We still might not know how many we need. We can see the finished product up here shows us, but when we're actually drawing this for the first time, we might not know how many we need to get down to the bottom. So we'll just draw it a bit further than we think, and then close. Now we can use the polyline command to just follow the intersections until we get down to the basement. So if we're just going to trace it rather than using the trim option, we wouldn't have had to explode the array. So I'll just cancel that, and you get the idea. In this case, I'll go ahead and delete that array, and then all the lines between the floor, and you can see we end up with a proper stair. Now I could actually take this, just to finish this quickly, and copy that, and then trim it. So there's a completed example. The next thing we're going to want to do is add a dimension, letting the contractor know how many risers there are. So the dimension initially just tells us the distance. It's 9 feet. But often we like to see there's 16 risers at, and then how many risers there are equals 9 feet, or the dimension of the riser. So we'll select the dimension, right click, and open up Properties, and then under Text we can scroll down. You can't spin your wheel, you have to use the scroll, and we can do the text override. So if we were to just type something in here like test, we can see it replaces the entire value. So we could type 16R at 6 3/4 equals 9 feet, but then if the value changed, the 9 foot wouldn't update. Of course, the number of risers or the size of the riser would have to change, but we have a way of entering in a couple of characters that will place the correct value in there. So if we do 16R, the at symbol, 6 3/4 inch, and then the equal symbol. Now if we type a less than and then a greater than symbol, that tells AutoCAD to insert the actual dimension. So again, if this floor-to-floor height changes, the overall dimension will update. The size of the riser or the number of the risers are wrong now, but this will be a clue that those two don't equal that total. So hopefully that would be caught before it was started, before construction was started of that stair. So that's a quick look at some of the section related features.